Hello. So welcome to a quick run through of Ultraleap's XR design guidelines. So this presentation was predominantly an internal one I used to give at Ultraleap, and it's a run through of our design guidelines, which are a document that's on Ultraleap's docs website that essentially is a number of different pages that tell you how to best design for XR and hand tracking. These guidelines were built up over about a decade or plus worth of XR interaction research from a bunch of different designers. So this isn't just my work, but the most recent iteration was predominantly written by me and a designer called Matt Corral. So a special thanks to him for this. So in this presentation, I'll be giving a quick run through of it, and there's tons more useful detail online where I'll link in the description. So, first of all, getting started. Let's go through some principles and design considerations for hands-first experiences. So, first of all, design principles. These mainly come from people coming to Ultraleap who are used to designing for controllers, and they kind of ask, well, what's the difference for hands? So the first thing that we always tell people is to make interactions physical. When things are 3D and physical, they tend to make more sense to users. But there's a number of asterisks next to that because physical maybe isn't the best word. Instead, it's more trying to design around routing interactions in users' prior contexts. But that's not as catchy as physical. And physical kind of, sums together the vibe of that. Essentially, what we mean by this is if you're able to design an interaction, whether it's a gesture or physical direct interaction, try to draw on your user's prior contexts and make things familiar and understandable and intuitive to them rather than needing to teach them something new. When you do need to teach something, it may be because you're using a pose. And we tend to recommend using poses sparingly. They can be really powerful, but difficult to pick up quickly. They're often very abstract and people tend to go a little bit too haywire with them. So they're more of an advanced design tool that you should use once you're used to designing for hand tracking rather than the first thing you pick up. Extra feedback is really important because with hand tracking, you lack some of the haptic feedback you get with controllers. So you need to be able to boost your senses through other means. For example, the button on the screen here, it has a hover effect and a effect when you press it, so it changes color. And if there was sound to this presentation, you'd also hear some nice down and up sounds. So another 3 design principles are comfort, interaction zone, and occlusion. So designing for comfort is really important because first of all, you're in XR, objects can be all around you. You need to be conscious of where your user is interacting and how comfortable it'll be for them to interact there. Secondly, you're not going to be holding a controller. When you're holding a controller, your hand is perfectly put into this lovely, comfortable position. However, with hand tracking, you're not forced into that. So as a designer, it's up to you to make sure your user's hands are nice and comfortable and not in awkward positions. You need to design for the interaction zone. When designing for hand tracking, you've got to be aware of the technological constraints. There are tracking limitations because your hands are being tracked by optical cameras. This means that your hands can't be tracked if the cameras can't see them. You need to take this into account. So don't design interactions where users are encouraged to take their hands out of view. And you should notify users subtly when their hands are beginning to get to the edges of the field of view. For example, here we're fading them out. And finally, let's talk about occlusion. So there are 2 types of occlusion. The first is shown in this picture, which is self-occlusion. And the easiest way to do it, as I've got a camera pointing at me, so you can see this in the next finger, now you can't. The same thing applies when you're using cameras. Sometimes they're not going to be able to see your fingers because your hand will be obscuring it. You want to try and avoid situations like this where you're relying on fingers that are obscured and instead design your UI to get around this. The other type of occlusion is hand-on-hand occlusion, which is very straightforward. It's when one hand blocks the view of another. Again, we can still track your hand when you're doing this, but the fingers that are occluded from you won't be tracked correctly or may not be tracked correctly. So you need to try and avoid relying on them being tracked correctly in scenarios like this. Virtual hands. So user embodiment is highest when you use the correct size, proportional hands in a clean visual style. So what do we mean by that? So getting hands correct is incredibly important for user embodiment. Users really want to feel like their hands are their own. So hand size, finger scale, finger length are all really important to this. And you can go crazy. You don't necessarily have to stick to human hands. So you could do, say, monster claws, alien hands. You may want to try and, build a sense of understanding for people who may not have all their fingers, and you may go for something else like that. But generally, if you're trying to build an embodied experience, you want hands to try and match the users. We tend to recommend doing this by using more of an abstract hand style, such as ghost hands, because realistic hands, unless they're taken directly from the camera feed, like in the Apple Vision Pro, tend to give more of an uncanny feeling. Everyone's hands are different, and people will notice if their VR hands aren't the same as their real hands. Finally, consider adding forearms, especially if they're tracked by the hand tracking system like Ultraleap. They're really great for increasing the sense of immersion because it kind of begins to attach you more to your body. So next up, we've got tutorials. Now this is really important because users of XR tend to be fairly new to it, and especially new to hand tracking. Hand tracking really then needs really good tutorialization and teaching in order for people to feel comfortable using it. We've done a bunch of different tutorial systems, and a lot of them are listed on the design guidelines online, but I'll take you through three of the main ones here. So the first one is simple hints. These are really useful for drawing user attention and introducing physical interactions. So they're low effort, quick nudges. They're just little text bubbles like you can see on the screen there, attached to interactions, and they disappear once the interaction has been done correctly. They're really useful for giving an instruction for something people already know how to do, but they're not great for introducing new concepts because they're just text. If you do need to introduce a new concept, maybe one of the other two tutorial techniques I'll discuss here will be helpful. So the first is help panels, and these offer a series of animated tutorials that are available at any time. We use these extensively on our launcher we built for our Ultraleap apps, and they're really good when users are stuck or unsure because they're always there, they're always available, and you can just press the help button and you get told what you need to do. Characters are another really, really powerful tutorialization method. They are non-playable characters who essentially walk through the same interactions as you, and you can copy their actions in order to complete the interaction. They tend to be pretty foolproof, and users will copy them as closely as they possibly can, but they do take time. For example, they're not great for interactions where you're up against the clock, such as, I don't know, if you're on a trade show floor and you're trying to get loads of people through your stand, or if you're doing procedural training and you need lots of people to come in and you need to make sure they're getting through that interaction really quickly. So a halfway house between help panels and characters may be ghost hands, which is where a hand appears and kind of does the pose or action on a control and then disappears. MRTK, if you search MRTK hand coach, you'll find some really good guidelines around that. Okay, so now we know some kind of design principles. Let's talk about interactions. So at Ultraleap, we tend to split interactions into two categories. The first is physical interactions. These are intuitive. They require little to no instruction, and they're close to how things work in the real world. So very similar to our first design principle that we talked about. Examples of these are grabbing objects, or picking up objects, throwing them, pushing buttons, all of this sort of really good physical interaction. The other sort of interaction type in XR are learned interactions. And these are interactions that can only happen in VR or AR. So they need to be taught or learned. Examples can be locomotion or opening UI panels by pressing a virtual button next to your hand. And these can be really easy to use once learned, but they've got to be introduced via help or onboarding content. So next is direct or distant interaction. And VR applications can work in one or two distinct interaction modes, maybe both at the same time, but that's rare. So the first is direct interaction, where people are grabbing objects and using UI components directly, much like in real life, much like our physical interactions we were talking about earlier. Distant interactions, I mean, this is pretty simple, right? It's where people are grabbing and using objects that are far away from them. And distant is more useful in mixed reality or augmented reality contexts because you can't necessarily teleport over to an object. You have to bring it to you or interact with it from a distance. Next up, now that we understand the kind of different styles of interactions, is locomotion. And there are two distinct types of locomotion, teleportation and free locomotion. So let's break each one down. So teleportation has 3 steps: enable, aim, and activate. We've got an example here of jump gems, which is our primary way we like to teleport with our hands. And this kind of follows these steps. So enablement is by looking at your hand and grabbing the gem. You then aim by moving your hand, and then you activate by releasing it. Really simple. Free locomotion, on the other hand, has similar steps. It's enable, move, disable. So this move, rotate, scale locomotion on the right here, where the user is kind of moving themselves around this world and scaling themselves up and down. Similar to like Gravity Sketch or Touch Brush. This follows these steps by simply enabling by pinching. So you pinch one hand to move, 2 hands to kind of rotate and scale. Then you move by doing just that. And then you disable by unpinching. And you can imagine that maybe here on the enablement step, you might need something a bit more to prevent accidental interactions. Both of these do share that enablement step as well, and that is really the hardest part to design for locomotion. And there are 2 different ways you can think about designing that. The first is stateful, and the second is contextual. So stateful locomotion enablement is where you are either in the locomotion state or out. So jump gems, I'm in it because I'm pinching it, and I'm out of it because I'm not pinching it. Contextual is a harder one to design for, and this is where the entire app is kind of built around understanding your intent for locomotion. So it may be that you've got an app built of different stations, and when a user looks away from a station or towards another one, you can enable a locomotion and let them teleport over there. And you can imagine this would be really useful with something like eye tracking to do. It's a lot harder though, because again, you do have to build your entire application around it. Okay, so I promised I'd go back to hand poses. So what is a pose? So first of all, a pose is when a user holds up their hand in a distinct position in the air. They're really, really powerful because they're essentially kind of shortcuts into an interaction, but they can be really difficult to teach. And you need to make sure you teach them in order to make sure users understand them. Poses can seem deceptively simple to someone who's designing it yourself because you have the entire kind of design system in your head, whereas a new user coming to it can be really easily overwhelmed by too many poses or gestures. So you need to make sure that poses, they're not accidentally activated, they don't overlap with any other interactions you may have, and they're easy to memorize. The other thing about poses is that they're really useful for social contexts. So, for instance, here you're interacting with a non-playable character. If you just tell the player to do a thumbs up, they know what that is. They don't need to be taught it. It's just simply something they know from prior interactions in real life. So considering your user's prior context and building that into poses is a great idea. Okay, so now we understand the kind of different sorts of interactions, what sort of components are available to us to use as designers. So first of all, there's loads. There's just so many. Components are infinite. You know this, we know this. But some are more traditional, like from the realm of 2D design, and some are more VR native. but the majority of them are going to have some form of depth and reactivity to them. So to take a more traditional example, the keyboard animation at the top, buttons are lifted off of the surface. So they're more kind of using this depth, and they respond to your touch. They move as you press them, and they respond to your proximity as well, in that when you hover over them, they turn a different color. At the bottom here, we have micro handles from a application called Cat Explorer, made back in the Locomotion days. And these micro handles have a few different states. So they react to your proximity by jumping to your pinch position or to a forward being pinched. And they then react to your pinching by shrinking. So you can see from these two examples different ways of bringing in some sorts of depth and reactivity. So next up, virtual objects. How can we naturally interact and pick up and move virtual objects with hand tracking? And there are different ways of doing this. There's not just one way. So as we were talking about controllers earlier, controllers are pretty simple. You tend to have binary fixed poses. So I am pressing the button, I'm not pressing the button. I'm moving left, I'm moving right. Pretty binary. Occasionally there's a bit of a digital analog divide there, but for the most part, users are happy with these fixed binary poses when using controllers. When it comes to hands, things are a bit more difficult because the level of embodiment is so much higher. So users begin to expect things to work the way they would in real life. And there are different ways we can design to get around this and help users here. So the first is soft contact. This is where your hands kind of meld through objects and always stay one-to-one with the tracking data. This leaves you in direct control of your actions because your hands are always where your real hands are. And it's really good for augmented or mixed reality because in those scenarios, you don't want your virtual hands to be in a different position to your real hands. If you're fine with that, say in VR, you can use hard contact, which is the GIF at the bottom. And this is where your hands wrap around objects and can be affected by the scene and affect the scene in turn. So in these scenarios, your hand, say I'm grabbing this tape measure in VR, my virtual hand may be like this, but my real hand may be like that. And the two kind of data hand versus actual hand are kind of out of sync. So this can be really difficult for scenarios like AR, but in general, it does add more of a sense of realism to your VR experiences, and the level of embodiment is higher. So I often feel a lot more ghost haptics when I'm doing hard contact. Finally, there's kind of an in-between state of these with pose snapping, where you grab an object and your virtual hand snaps to a very specific pose. So say I wanted to teach someone how to hold this tape measure. I would grab it and then my hand would snap to this pose because the little finger has to be up. And then you'd be able to teach someone how to hold it. Pose snapping is really useful for getting a really clean visual style out, but the level of immersion and realism is lowered because your hands can no longer move as freely. Okay, so how do we design objects for hands? First of all, make sure you design with affordances in mind. So physical objects convey information about their use. So a doorknob affords turning, a chair affords sitting, and well-designed virtual objects provide clues about what can be done, what's happening, and what's about to happen. So, for instance, this grooved ball here really affords being picked up from the grooves. Similarly, you want to be able to signal an object's interactivity. So you want to help users understand what they're able to interact with and how to interact. The example here is any object that can be picked up has a little label that floats above it. Finally, object size affects user behavior. So if you're picking up a small object, users will tend to pinch it. More medium objects, users will grab it with their whole hand, and larger objects, users will grab with both hands. And this is despite the fact that users could, say, pinch the larger object or grab smaller objects with both hands. Users tend to go with their instincts here, and these object sizes kind of afford these specific hand poses. So you can use this to try and design around and make sure users are doing the correct hand pose you want them to do. UI panels are interesting one. They're a bit easier to design for than the rest of XR because they're more rooted in this traditional 2D context. But there are a few different things you can do to kind of help yourself and help your users interact better with them in XR. First of all, we recommend raising buttons. The button should be raised off the panel if they're pressable, and they should move towards the panel when pressed. Selected buttons should then appear depressed, like the apps button here. You want to be able to curve the screen so that components are always within reach. Our arms don't move in straight lines. They move in nice curves because we're connected to joints. And so you need your UI to reflect that. Users should never need to fully extend their arms or stretch out to reach any controls because you need to consider comfort here. In addition to this, grab balls or moving panels, adjusting panels, allowing users to kind of bring the panel into a comfortable zone that they choose is really helpful because everyone is built differently, everyone's arms are different, everyone's hands are different, and being able to personalize where things are in their spatial zone can really help with comfort. Finally, when considering cursors, don't use them for physical direct interaction. Your fingertip is a good enough cursor, but instead only use cursors for indirect interaction, so far field interactions with UI panels, because then you kind of give users a sense of precision. So finally, we'll talk about some wearable components, mainly here the hand menu. So hand menus are a real signature interaction paradigm for hands. They appear when your hand is facing you, and this is because you don't tend to be interacting with anything if your hands are like this. And they're really quick access when you're on the move because they're always attached to your hand. You can think of them as the equivalent of buttons on a controller in that you can press them and immediately get something done. You should keep hand menus small because if they're too long, it feels like you've got a massive plank. And the further away the UI is from your hand, the more your hand tremors are accentuated. So you need to keep them small and easy to use. So that's it for now. If you want to learn more about hand tracking and XR design, definitely check out the Ultraloop docs where we kind of go into much more detail around all of these things. If you have any questions, feel free to message me or comment below and I'll do my best to answer them.